now we can move into loading our assay data. So that to load the assay data, it's going to be a very similar procedure to what we have been doing. So first I will go ahead and do read CSV data, look for my assay data, select that so I can run this cell. So now that I know what the columns are in my data, I can start typing the actual RMSP object that I want to load this into, which is rmsp.interval data. So interval data is the object in RMSP for loading all data within intervals, and that's the case for assay data or geological logs, for instance. If I press Shift Tab, I can look into the documentation and look for my metadata. So the most important metadata that we are looking for is drill hole ID, I from, I2, X, Y, and Z. Actually, no, interval data might not have actual X, Y, and Z. So that's why it says it's optional. So in this case, we only have the assays. We do not have any coordinates. So our metadata is going to be just the first three. So let's go ahead and do drill hole ID equals 2, and then I can copy from here. Then we can do I from equals 2 from. Note that this metadata is not called from, and the reason for that is, as you can see, it has turned into green color. So this is indicating that this is a Python reserved name. So if we name a variable with the same name as a Python reserved variable, that's not good practice programming. So to avoid that, what we do is to add a I at the in front, and we call it I from. And the same thing is true for 2. We add I to the front, and we use that as the metadata. So let's copy the 2 column and close the parentheses. And again, I can press Shift B for auto formatting. So this is going to create a interval data, and a interval data is a geodata frame. So we can do check value ranges as usual, and I typed it wrong, so let's do it again. Dot check, and then press tab, Shift tab, underscore. So check value range, that's what I want. And then we can check inside the function, get the show meta, and do equals through. So we see all the metadata. So this loaded all the information inside that assay. And you can see that it breaks down the columns for us nicely. We can see the continuous variables. We can see the categorical variables. In this case, categorical variables is just the drill hole ID. And the continuous variables that we have inside this data are the copper, element A, element B, element C, and element D variables. And density as well. Another thing that's new on loading the assay data that I have not mentioned yet is that we can see that the minimum value for copper, element A, element B, it's all minus 999. I could take care of that right now by specifying another argument on my interval data, which is specifying what is the missing data. So for now, I'm not going to do that, and we might come back to this. But first, I want to illustrate what happens when I have that kind of information. So let's go to the next cell. And now we want to validate the assay data. Again, we have the .check function. For assay data, we can check what is tested for assay. So for assay, we have duplicate records, missing values, invalid interval length, unexpected gaps and unexpected overlaps in our intervals, mixed data types, repeated values, and invalid numeric values. So let's see how this validation looks like for us. But before that, we want to set the report and the ignore warning. So I want to see a summary, and I want to ignore the warnings. So if I run this, there's no issues at all. The one thing that's new on this check function, because this is assay data, so we expect that we might have some extra variables that are useful to us. So for instance, I can specify variables. So in our case, let's get some variables from here. I can do list and the data frame. This gives me the columns back. I can copy all the variables that are relevant to me, and I can call these variables and put that in the list, and maybe just copy that to the same cell, delete the cell, and do var equals variables. Oops, I pressed Ctrl V here. Var equals variables. There you go. And now we can press Shift Enter. And what this is telling me now is that, okay, so I have specified the variables that are useful to me, that I expect to be using, and then it's checked those variables as well. So what's this telling me? That there are invalid values, and this is how many invalid values are in this data set. And typically this is coming from a negative number. It might be the missing value, or it might be some other negative value. We know copper cannot be negative, so that's just a issue to have negative values. So let's start now then handling the missing data. So as I said, one of the places where we can handle the missing data is when we are actually reading the data and loading that into a RMSP object. So I can specify missing equals, and then look at this information, I can tell that the missing is -999. So I set missing to -999, and now I can reload the data. And let's check the minimum values now. So now the minimum values are all 0 or positive. So that tells me that at least the negative number problem should be fixed. So if I validate the data again, it returns a empty data frame. So this is just telling me that all there was to the problems that I found was related to the missing value. So by correcting the missing value, I have fixed the issue with the data. Now we can load the geology log. Geology log is also a interval data. So the procedure here is going to be very similar to what we have for assay data. So I'm going to be calling this geolog, and I will start with pd read csv and look into my data folder. What I'm looking for is this geolog, and again I'm going to do a .head to investigate what is inside. So now we can convert this to RMSP object. So RMSP.interval data, and we already know that the metadata here is drill hole ID, which is this string, and then I from is equals from, and I2 is equals to. So this is all I need for this data frame. And of course, because now it's interval data, I can do a .check value range and show meta equals true. There you go. So what is showing that this data frame contains from and to, contains drill hole ID, and also contains another categorical variable, which is the geocode, which is my geologic logs. This is a interval data, so we can do a geolog .check, and of course the only variable that we have in here is the geocode variable, and we can quickly check, and because it hasn't returned anything, we can safely assume that this data set is fairly clean.